Alright, so given that theorem there, that we have a right angle here, every time we have that line in the radius, we're going to look and do a couple of these problems. So, we do actually, it says refer to the figure for problems 1 through 4. AB is tangent to C. What does that mean is true right here? CBA is 90 degrees. I'm going to draw that little box in there. That's 90 degrees. Okay. At point B. And AD is tangent at point, this should say at point D. So this is tangent here. What does that mean? I can find out what angle C is, you're right. But this is also 90 degrees. Alright, so here's what I need to figure out. I'm going to zoom in on the picture instead of the questions. Number 1 says we are supposed to find the measure of angle ABC. 90 degrees because of the tangent radius theorem. So ABC is 90 degrees. Okay, we're going to look at number 2. This is the one that you guys just said, hey, we could find this one, DCB. DCB, I'm going to put a little marker so you know where it is. DCB is right here. How am I going to find that? 90 plus 90 is 180. Okay. Then you add 40. Here's what he's doing. He's saying, hey, we have a quadrilateral right here, right? And how many degrees are in a quadrilateral? 360. So what is 180 plus 40? And there's 360 degrees in a quadrilateral. So we're going to subtract and get. So the measure of DCB is 140 degrees. Yes, you could also make it into 2 triangles. No idea. Like something didn't get cut off right or something. That's just the extra little piece that it shouldn't be there. Okay, now we know this is 140 right there. And we now need to find, number 3 says find BDA. This angle right here. We're going to learn in a minute that this actually is an isosceles triangle. So we're going to assume it is at the moment. But in the next theorem, we will actually learn it is. So if this is 40, how do I find out what each of these pieces are then? Okay, 180 minus 40, which is 140. Divide that by 2. 70. Okay. So this is 70. Because you had an isosceles triangle. Last angle there. CDB, right here. How do you know that's 20? That one is 20. You could also have done the same thing. Since this is the radius, these two are congruent. 180 minus 140 is 40. Divided by half is 20. Not divided by half. Divided by 2 is 20. Okay, so there are all those pieces. I want you guys to work on 5 through 8. Before you do, though, 5 through 8 is talking about the converse of the tangent radius theorem. Well, what is a converse again? the opposite. So now it's saying, hey, if the line is perpendicular to the radius, then it's a tangent to that circle. The problems are pretty much the same though. So work 5 through 8 with that measure given, and we'll go over those in a minute. Alright, 5 through 8. This is almost, other than the perpendicular segment, most of it is a review of stuff we've done in the past, which you may have forgotten over the weekend. But the measure of BCD here, can we find that to start with? Or do we probably need to find something else first? Let's move on and try 6 next. The measure of angle CDA, what is that? That's 90 degrees. Okay, so that will definitely help us find number 5, which we'll do since it's a quadrilateral. Okay. Okay, can we find BED yet? BED? I think we need to find something else first. That one probably threw you for a loop for a minute, and you'll see why. Alright, how about DBA? Can I find that one yet? I can. Yes, I can. How can I find that one? Okay. Let me see. It was I can't read. DBA. This one right here. Since it's isosceles, we'll get the theorem for why it's isosceles in a minute. 180 minus 32, what's that? And then we divide it by 2 and get, so BDA is 74 degrees. Alright, now let's do the other two. Let's do BCD first. So angle BCD, I know this is 32. I know these two are 90. How many degrees are there in a quadrilateral? Okay, so 90 plus 90 is 180. Plus 32. What's 180? Yep. You're right, I don't have to do 180 plus 32. Why? Okay, we can do that instead. It's the same amount of work, the same process. So he's saying instead of doing that, we could find this angle right here, right? What is 90 minus 74? He's saying then I've got a triangle. 16 and 16 is 32. And subtract that from 180. It's what? 148 degrees. That is BCD. Number 5 is 148 degrees. This is the sad thing about circles. There's a whole lot of stuff to remember. Alright, now, I want you to take a highlighter out. I don't care what color, you just need one. Because this next one is remembering a lot of stuff. We need to find BED. What is BED? It's an intercepted arc. Not intercepted arc. An inscribed angle. To find the measure of that inscribed angle, we need to know the measure of its intercepted arc. Do we know that? We do. Not 2 times C. The central angle and the arc are what? The central angle and this arc are the same. This arc is 148 degrees. What does that mean about this inscribed angle? It's half. What is BED? 74 degrees. Possibly, yes. Yes, we're going to see that in a minute. Alright, so in case you did not get those, here are all 4 of those solutions. 148, 74, 90, and 74. So we just realized that a circumscribed angle of a circle and its associated central angle are supplementary. We're going to draw that in. So draw this in and put A, B, C, and D. So what this is saying is that the measure of angle BCD plus the measure of angle BAD is equal to 180. That's what the theorem actually says. That helps, we know that these are 90 already because of the last theorem. Alright, but what else did we just figure out as well? Yeah, we just figured out that also AB is congruent to AD. We already knew that these were 90. What else did we already know? BC is congruent to CD just because they're radii. You know what shape this is? It's a kite. Yep. Alright. We're going to do some examples with that. Okay. So once you write that in a slide over, we're going to do some examples. 9 and 10. Okay, number 9. First we have to find x. What is true about angle P compared to angle Q? So 2x minus 7 plus x plus 1 equals 180. There's not a whole lot of room here, I know that, and I'm sorry. Alright, so combine like terms and you get 3x minus 6 equals 180. And then what? Add 6. So 3x equals, and then what do you do? So x equals, it's what? (62). That is x, not an angle, so do not put degrees. How do you find NQM? Substitute. X plus 1 becomes 62 plus 1. What is 62 plus 1? 63 degrees. Alright, how about P and Q? 90, because it's a tangent and a radius. Okay, and how about NPM? You can either plug it in, double it, subtract 7, or you can do 180 minus 63, which is what? 117. Okay, there's all the work for number 9. I want you guys to do number 10. Okay. What did you guys set up on number 10? Plus 2x minus 2 equals 180. Okay. 8x minus 12 equals 180. 8x equals 192. Divide by 8, and x is 24. Alright, then you plug back in. QMP. You didn't have to plug in on that one. Okay. MQN. Okay, so you do 2 times 24, which is 48, and you subtract 2, and you got 46. Okay. How about NPM? You can either subtract 46 from 180, or plug in and do 6 times 24 minus 10. Either way, you get 134. Alright, this goes glued in on page 125. The title is 15.3, tangents and circumscribed angles. If you cut anything out, you're going to need to throw that away. Not right now, but in a minute. Your assignment is on page 800 and something. 809. You are doing 1 through 4 and 9 through 15. Work on that for the rest of class.